Okay, so today's lesson 3.4, solving quadratic equations by factoring part 2. If you want to put a note here just so it's easier for you to find, part 2, really we're doing a lot of word problems today, okay? So in the previous lesson, it was more just um, the math behind it, just doing the sets, the problem sets, and using your factoring to solve for 0. But now we're going to essentially use everything from part 1 and apply it to word problems. All right, so otherwise we're doing the same thing. We're still solving quadratics by factoring, but now we just have them in word problem format. So let's look at example 1. In this case, we're dealing with a model rocket, okay? And the rocket flies in the air and then hits the ground. And we are given a equation that models this rocket's flight path, and the variables of interest is we're measuring height with respect to time, okay? So the height are your y values, and why is height y? That's because time is always your x values. Time is the independent variable, and we can also see that right here, h of t. Height is a function of time. So let's do 1a. What is the initial height of the rocket? Well, initial height, this part right here, says what is the height when t equals 0 seconds initially. No time has passed. Where does it start? So that means you are solving h of t when you're at 0. You're solving for the height when t is 0. So you plug in minus 5, 0 squared, plus 20, 0, plus 25. So this term goes to 0, this term goes to 0, and it's just 25. And what are we measuring? Meters. So this is 25 meters. I know I did the math here, but as you remember, this is given in standard form here. So the initial height is also your y-intercept, because the y-intercept is when time is 0 here. So that would have been a much faster way for you to find it as well. Okay, so part B. When will the rocket hit the ground? Well, hitting the ground, in this case, this means h of t is 0. The height is 0. So plug in 0 for your h, and that would be minus 5t squared plus 20t plus 25. Let me zoom in a bit here. Well, this looks awfully familiar from the previous lesson. We have 0 on one side of our equation, and we have all these unknowns, these t's here. Well, in order to solve for those t's, we are solving a quadratic by factoring. So let's factor this right-hand side here. We'll have 0 equals, well, first step in factoring says look for a greatest common factor. And in this case, I can pull a negative 5 out of each term. So that would be leaving with, t squared minus 4t minus 5. And now you have a simple trinomial because the a here is 1. So our simple trinomials is just simply looking for two numbers that multiply to give you minus 5 and add up to give you negative 4. Two numbers that multiply to give you minus 5 and add up to give you negative 4. So in this case, this would be minus 5 and 1, minus 5 and 1. And when it comes to simple trinomials, you don't have to do any of that decomp. These are literally your solutions. So one bracket will be t, and if that's a minus 5, it would have to be, plus 5. No, it would be minus 5, yep, t minus 5, and then t plus 1. Because if you distribute these out, right, if you check and you distribute these out, that's what I kind of just did there mentally in my head, you'll get the middle term and the back term. Okay. Well, when will the rocket hit the ground? Well, this is odd. Oh, no, because you're going to have a negative solution. When will the rocket hit the ground? Well, we got to look and we got to say, okay, t minus 5, when is that 0? T minus 5, when is that 0? Well, that would be 0 when t is 5 seconds. And this is why I kind of had a second guess there, like, did I do this right? Because if you look at this bracket, you might have two solutions, but t plus 1 equals 0. But in this case, when you bring the positive 1 over, you get t of minus 1 second. Well, is this solution possible? No. Time can't be negative. So there is only one solution. All right, so when it comes to these context of the word problem now, not every solution is valid. And because you have to think time can't be negative. Or like, let's say this was a distance problem. Distance can't be negative, all right? So this solution right here does not work. So therefore, the rocket hits the ground, at t equals 5 seconds. Or you can just say at 5 seconds. Okay, part C, graph the function. Well, let's plot our points. So in this case, we have a part A gave us a point, a x coordinate of 0 because time is x, and a y coordinate of 25. So at 0, 25, you have a point right here. And then you also have another point at 5 seconds right here. Okay. Well, can we graph this function? Can I just go like this and connect these dots? Well, no, because we're missing something very important. A parabola has a maximum somewhere up here, a maximum or a minimum. But in this case, I know that I'm going to have to kind of go on a curve down like this towards this point. So I know somewhere in here there's going to be a maximum. So how do we figure this out? Where do I put my point? Somewhere up here. Well, we need to figure out that maximum. How do we figure out the maximum? Well, start by finding the x-coordinate of your maximum. Recall, the x-coordinate, the h value of your vertex, is the halfway point between your zeros. So in our previous problem, we found one zero to be at 5, and we found the other one to be at minus 1. Yes, this wasn't valid. So technically, it's right here in the negative time space. Okay? But you are still finding the halfway distance between these points because it will kind of give you an indication, or it will tell you where the maximum is, the halfway point. So you still needed to calculate it. So finding that halfway point there, that would be 5 minus 1 over 2. So our h value in this case would be 4 over 2 or 2. But let's find the k value as well. The k value is the value of our function. I know we're going to use h here twice, right? But it's really h of t when t equals h, like the x-coordinate of your vertex, okay? So we are calculating our height when we plug in. So our k value is when we plug in h, our h value, for all these t's up here. So we have k, so this would be minus 5, and our h is technically 2 squared. And then it was plus 20t plus 25. Plus 20t, so t is h of 2, plus 25. So you'll get minus 5 times 4 plus 40 plus 25. So that's minus 20 plus 40 plus 25. Doing all that, you will get 45. And really, just to give you context of what you're doing, this h value, remember this is a x coordinate, an x value. But in the context of this problem, that is also a time value. So this h is actually at 2 seconds. And this k value, yes, it is a y value, but in the context of this problem, it is the height. So this is 45 meters. So that means we have our vertex. Our vertex is at the 2 seconds and 45 meters. So 245. So that means we can plot our vertex at 245. Right there. Now that we have our vertex, we can connect the dots. You then go from here up to the vertex and then come down to your 0. Perfect. So state the domain and range of this function in the context of this problem. All right, so domain is talking about what can x be, right? So in this case, x is measuring time, and the biggest value of time in the context of this problem is 5 seconds, and the lowest value right here is 0 seconds. So that means our domain is x can be real numbers, okay? Again, just say this. Just add this part, okay? This won't really come into play. You will always be dealing with real numbers until you get to maybe third year university. So x belongs to real numbers such that x's need to be greater or equal to 0, but less than or equal to 5. And actually, I shouldn't even put x here because in the context of this problem, it's actually time. Time is your x value. So time belongs to real numbers, and time has to be between 0 and 5. And you'll do the same thing for range. Range is talking about what can the y values be. And just as I corrected myself there with time, remember you're measuring height here, okay? You're measuring h of t. So in this case, the height can be any real number, but it needs to be bigger than 0. It could be 0 because it has a y value of 0, h of t equals 0 here. So h has to be bigger than 0, but what does it have to be less than? Well, that's your maximum right there. There's 45 meters. So it has to be less than 45. And there you go. That is your domain and range. All right. Example 2. The Wheelie Fast Co. makes custom skateboards for professional riders. The company models its profit with the function p of x equals negative 2x squared plus 14b minus 20, where x is the number of skateboards in thousands, and this shouldn't be a b, this should be an x here, okay? So change that on your notes. It should be x. Where is x in the number of skateboards produced in thousands? And p of x is the company's profit in hundreds of thousands of dollars. All right, so what does this, where x is the number of skateboards produced in thousands. So what that means is, let's say we solve this whole thing. And let's say we find a solution to be x equals 4. Well, what that means is you actually produce 4,000 skateboards, because x is measuring the number of skateboards produced, but in thousands. So you'll get 4 as a solution, but you have to understand that that is measuring actually 4 thousands. We just make the numbers smaller so it's easier to look at. And the same thing with p of x, in hundreds of thousands. So let's say we find our maximum profit to be, 1, just making numbers easy. Let's say maximum profit was $1. Well, that $1 in hundreds of thousands of dollars would represent actually $100,000 of profit. But we're not going to graph 100,000. We're going to graph $1. So we just have to understand this scale conversion here, okay? So example 2A. How many skateboards must be produced for the company to break even? All right, so break even in the terms of like business and is when profit equals zero. All right, it's essentially when your costs and your revenue are the exact same. So you haven't made money, but you also haven't lost any money. So in the context of this problem, this is when P of x equals 0. So if we have our P of x equation, P of x is minus 2x squared plus 14x minus 20. Again, replace that b with that x. Well, we're setting our profit to 0 because we're looking for when it's break even, and we're looking for the x values that would make the left-hand side 0. So we are given a quadratic here, and we're looking for our unknown to be x. So we are solving this. So we need to factor. Check, can you take a GCF out? Yes, we can. We can take a negative 2 out from all of these. So we would get, and I'll just work in one color again, 0 is take a minus 2 out first, x squared minus 7x plus 10. And again, you now have a simple trinomial. So look for two numbers that multiply to give you 10 and add up to 7. So multiply to 10 and add up to 7, or negative 7. Well, in this case, that would be minus 5 minus 2. So then your factors, again, it being a simple trinomial, is just x minus 5, x minus 2. So we need to figure out what are these x values here that make this equal to 0. So take x minus 5, set it to 0. So x of 5 is one solution. And then you have the other one right here. X minus 2, set that one to 0. And that would be bring the minus 2 over, x equals 2. There is your other solution. So how many skateboards must be produced for the company to break even? Remember, x represents the number of skateboards. So in this case, when x is 5 and 2. But also recall we're measuring these in thousands. So therefore, we need 5,000 skateboards or 2,000 skateboards. So remember, you're measuring in thousands, okay? All right. Part B. How many skateboards does Wheelie Fast Co. need to maximize profit? Produce. I should say produce. Sorry for the mistake. Produce. Need to produce to maximize the profit. Well, when you see this word maximum or minimum, when you're in the quadratic unit, your brain needs to think vertex. And we want to know how many skateboards to find the vertex. Well, essentially, we're trying to find the h value of our vertex. Okay? So we're looking for this right here. Well, how do we get h? Well, remember, h is the halfway point between your zeros. So we have one zero being 5 and the other one being 2. Divide those by 2. That means 7 over 2 or 3.5. So recall, again, this is h is a x value. Right? This is a x value. It is the x value of our vertex, but in the context of this problem, because it's an x value, it is also the number of skateboards. That's what it represents. So that means we will have a vertex when the number of skateboards is 3.5. Or, how many needs it produce? Therefore, Wheelie Fast Co., WFC, needs 3,500, okay, not 3.5, 3,500 skateboards. Sorry, boards to maximize max profit. Well, what is the maximum profit? Well, in this case, now we're looking for the K value, okay, because the K is dealing with the Y values, and we are measuring P of X. So we're measuring Y values with respect to X. We're measuring profit with respect to number of skateboards. So we're looking for the K value, and the K value will tell us the maximum profit. So take P of X and calculate P of X at our H value, which was 3.5, okay? So calculate P at 3.5. And we'll have to use our calculator because this is not a nice number. So our P of X equation is minus 2x, or I'll just write the P of X first, 2x squared plus 14x minus 20. Okay, so now calculate P at our H value of 3.5. So 3.5, this is our H value. So plug 3.5 in for this x, plug it in for this x, and then take away 20. All right, so use your calculator. 3.5 squared. So this first term is minus 24.5. And then we have 14 times 3.5 plus 49 minus 20. All right, so then minus 20 minus 24.5. We'll get 4.5. Okay, so that means your maximum profit happens at 3.5 on the H, but the maximum profit is 4.5. But once again, this is measuring in hundreds of thousands. So really you have to take this number and multiply it by 100,000. So therefore, max profit of, and then multiplying that by 100,000 is you're going to shift the decimal places 1, 2, 3, 4, 5, right? So it'd be 4, 5, and then what you have 4 left over. 1, 2, 3, 4. Oops, sorry. So 450,000. I don't know why it took me so long to do, but max profit of $450,000. Okay, last question, and then we're done. So the path of a dolphin travels when it rises above the ocean's surface. The path of a dolphin travels when it rises above the ocean's surface can be modeled by something grammatically there, by the function h of d equals negative 0.2 d squared plus 2d, where h of d is the height of the dolphin above the water surface and d is the horizontal distance from the point where the dolphin broke the water surface, both in feet. What is the horizontal distance of the dolphin when it is a height of 1.8 feet? Okay, that was a lot. So, what's the question asking? Well, what is the horizontal distance? Okay, so we're looking for, in this case, what? H of d is the height of the dolphin, and d is the horizontal distance. So in this case, the question is asking us for d, so we don't know d, and it is saying find d when h of d is 1.8, and in this case, we're measuring in units of feet. So you are given a h of d equation. We have h of d equals, oh, sorry, that is a negative, negative 0.2 d squared plus 2d. So now substitute 1.8 for this. So 1.8 equals negative 0.2 d squared plus 2d. All right. Oh, sorry, that's a d. And that's also a d. Negative 0.2 d squared plus 2d. Well, this looks like a quadratic. And when we are solving a quadratic, because we are solving for this d value right here, we're looking for d. Let's solve this, and the first step is to set it equal to 0. So we need to bring this over to the side right here. So 0 equals minus 0.2 d squared plus 2d minus 1.8. Okay, so now let's factor this. But clearly we have this negative 0.2 in front here that's throwing us off. We have all these decimals, all right? Well, let's get rid of the decimals. Or let's get rid of this 0.2 here. So let's factor it out. So we'll have 0 is minus 0.2. We factored it out, so that first term becomes now just d squared. Well, what is positive 2 divided by negative 0.2? So if you don't know, take your calculator, go 2 divided by 0.2. How many times can 0.2 go into that? All right, so in this case, we get minus 10 d. How many times can 0.2 go into negative 0.2, go into 1.8, right? This can go into it 6 times. Actually, yeah, 6 times. Plus 6. So now we can factor this. That's a simple trinomial where you need two numbers that multiply to give you 6, and same two numbers have to add up to give you negative 10. All right, so what are your multiples of 6 that will add to negative 10? Actually, nothing in this case. So this is actually going to be a quadratic equation problem because you will not be able to take anything here. Like there's no 6 and 1 or 2 and 3. No combination will work. So in this problem right here, we can't factor it normally. So we need to use quadratic equation. Need quadratic equation. So let's use quadratic equation. The quadratic equation is x equals, well in this case we're not dealing with x's, we're dealing with d's. So d equals negative b plus or minus b squared minus 4ac all over 2 times a. And you can take it from this step right here. Okay, we'll use those nice clean numbers. So d equals, well, our b value, this is our b, this is our c, this is our a. So our b is minus 10 plus or minus 10 squared minus 4, our a is 1, our c is 6, all over 2 times 1. So we get d equals 10 plus or minus 100 minus 24 all over 2. So then d equals 10, oh, I'll keep it in purple, 10 plus or minus the square root of 100 minus 24, so 76, all over 2. This is not a nice square root, okay? So use your calculator. So square root of 76, I get 8.72 after rounding. So d equals 10 plus or minus 8.72. Yep, 72, trying to double check. Over 2. So that means you have one solution when you're dealing with the positive. So D equals 10 plus 8.72 over 2. And doing that, plus 10 divide by 2. You'll get a distance of 9.36, and we're measuring it in feet. And then you'll have to do the other one where it is in the negative here, right? So then you do that math, and you'll get D equals 10 minus 8.72 over 2. And so you do that math, 10 minus 8.72, divide that by 2. You'll get a distance of 0.64 feet. So there's two valid solutions. Okay, so context problem. What is the horizontal distance of the dolphin when it is at a height of 1.8 feet? Well, at 1.8 feet, it is at a distance of 9.36 feet and 0.64 feet. So if you think about a picture of like what that probably happened is, you know, you have this water, right? The dolphin goes up, right? Hits at 1.8 feet there, and then it comes down once again, and that happens right here at 0.64. This one happens at 9.36, right? So it hits this 1.8 twice. So that's why you have two solutions. Okay, word problems are tough. We have lots of practice, right? Bye for now.